Let's talk about how we can graph higher degree polynomials from factored form. And I'm going to kind of follow a process here where we're really going to get a general idea of the graph. We may not get every part of this right, but we're going to get an idea. So to begin with, we want to note the highest degree because that's going to tell us the shape. Then we're going to note what the x-intercepts or the numbers that would make the function equal to 0 are, and we'll note the multiplicity of each of those. And finally, we'll get the y-intercept by making x 0. So let's do an example. X minus 4 times x plus 3 squared. So the first thing I would do is note the shape, or degree, I should say. Now I have an x here, but then I have an x squared that would come from this. So x times x squared, of course, is x cubed. Now here's what this means. I would have an x cubed, and there's going to be a lot of other stuff that comes after that. If I multiplied this thing out, if I took the time to actually expand it. But all I need to care about is that the highest power is going to be x cubed. So that is my degree. My degree is 3, which, if you remember, the shape of anything that's odd degree is kind of that where it's going down, starts off negative, going down here and going up here. The next thing we're going to note are our zeros. And again, this is what makes the function 0. So in factored form, we look at each factor and we say, well, what would I plug in here that would make this factor 0? Of course, it would be 4. So let me write that down as my 0, 4. And the other one would be, what would make this 0? Of course, negative 3. Now, multiplicity refers to how many times that factor appears. Well, this one, it's x minus 4. There's nothing written here. And of course, if there's nothing written, we assume it's to the first. So this is an odd multiplicity. It's got multiplicity of 1. I'm just going to put odd after that. Negative 3, on the other hand, because this factor is squared, its multiplicity is 2, and that's even. Now, what that means is that we know now if it touches but doesn't cross the axis, or if it crosses through. So odd multiplicity crosses through the axis, even multiplicity does not. So I'm going to put those down here. I'm going to put negative 3 and positive 4, like that. Okay. Now, the y-intercept. The y-intercept is what we get if we plug 0 in for x. Okay. So I'm going to do that. Let me just write down that work. We'd have 0 minus 4, and then 0 plus 3 squared. Okay. So 0 minus 4 is negative 4. 3 squared is 9. So it'd be negative 36. I didn't plan this real well. That's obviously way off the page. Okay. But that would be way down at negative 36 down here. Okay. So let's do a rough sketch using our shape and our zeros. Okay. So we knew that it would start down here. At negative 3, it's going to touch but not cross because it's got even multiplicity. It's going to go way down. I'm just going to pretend that goes off the screen there to negative 36, and then it's going to come back through 4 heading up like that. That is what my graph would look like. Okay? Let's do another one. All right, so to begin with this one, x minus 1 squared, x plus 1, x minus 2, I like to just kind of note the degree. So we've got x squared, and then x and x. So x squared times x is x to the 4th. So this is a 4th degree, which means its shape is going to be something kind of like this. Okay, any even-powered degree is going to go up in both the positive and negative, going out to positive and negative infinity. Okay, the x-intercepts, what would make each factor 0? Well, this Of course, 1 would make this 0, and that's got multiplicity 2. So I'm going to write 1, and I'm just going to write that after multiplicity 2. That's, of course, even. Next up, we've got negative 1 that we would plug in here to get 0. And because that factor is just raised to the first, that's got multiplicity 1, which is odd. And then, of course, 2 plugged in here, 2 minus 2. So 2, multiplicity is also 1, and that's odd. So I'm just going to mark those in there. We've got 1 and negative 1 and 2. And 1 has even multiplicity, so we're going to be just touch that but not cross, and the other 2 will cross through. Okay? Now, y-intercept is what happens when x is 0. So I'm going to write that down. We got 0 minus 1 squared, 0 plus 1, 0 minus 2. So negative 1 squared is 1, 1, negative 2. So my y-intercept is negative 2. It's right here. All right, let's do a rough sketch of this. So because it was x to the 4th, it's going to end up like that. We're going to cross through negative 1. So we're going to go like this. Of course, we got to hit our y-intercept. We're going to go up, touch, but not cross through because that had even multiplicity, and then cross through 2 like that. Again, we may not have all of the values correct, but we have a really good sense of where the graph is based on the shape with the degree and the x-intercepts and y-intercept. Okay, so this is the process I would go through. Figure out the degree, figure out if I multiplied it out, the x's, what would the highest power be? That'll tell us the shape. Remember, all odd degrees do that, and evens do this. Of course, that could switch based on if I put a negative in front, it could reflect it. Then the x-intercepts are just whatever would make each factor equal to 0. And note the multiplicity so we know, does it just touch this 0 or does it cross through? If it's raised to an even power, it touches. If it's raised to an odd power, it crosses. And then the y-intercept, just plug 0 in for x because we're looking for where it hits this line when x is 0. Okay? If this video helped you, please like and subscribe for more math help.